Okay, that's what happens here. Now, are there any questions on this? Okay, something else I want to say, I forgot. All right. Okay, that's good. Oh, sorry. All right, so let's keep going then. If you have, that's what I want to say. If you have trouble, obtaining this answer using a calculator, make sure you're typing in the numbers in the right order. And if you're still struggling, contact me, okay? Just letting you know. All right. Oh, that's what I wanted to say also. Now, is there a formula to get the total interest? Like in simple interest, right? There was a formula, that's what capital I was, to get the total interest. For this, I don't know off the top of my head. So that's okay for now. I want to say there is, but it might be complicated. But anyway, let's do another example. So now we're investing $10,000. Okay, we'll just say good. $10,000 into an account. It pays 6% interest, and it's compounded monthly. Okay, so monthly, right? There are 12 months in a year, so that tells us it's being compounded 12 times a year. Since that's actually what the savings account I have at my bank, that's what it does. It compounds once every 30 days, so like once a month. Calculates a percentage of what I have in there, and then that percentage, it adds on to the account. All right. Now, 6%, that's our APR, our annual percent rate. We want to know how much will be in this account 2 years later, how much the account will be worth. Okay, so it's just like the other example, right? We have $10,000. That's our initial amounts. That's our P0. Our R is 0.06, right? That's our APR, but you're writing it as a decimal. Being compounded monthly, so as I just said, 12 times a year, so N is 12. So we want to know how much will be in the account, what's the value of it 2 years later. So T is 2. So we're using this formula. So we have $10,000 times 1 plus 0.06 over 12 raised to the 12 times 2, as you can see. Okay, so again, using the formula, we have P0 times 1 plus R over N to the N times T. Right? So again, in your calculator, we have 1 plus this, R over N. That's what we're doing first. The exponent is 12 times 2, which is 24. So we raise it to the 24. That's how we get this number. Notice also that I said to round it to 2 decimal places. I'm using more than 2. I'm actually using, looks like 5. So, you want to use as many as you can. And then we multiply and we end up with this. So 2 years later, the account will be worth this amount. Okay. Okay, so we have that example. Good. All right. And then we have another one. So now let's put $4,000 into a savings account, okay? Okay, first let's consider if it was paying 8% simple interest. Wait, sorry, let me read the question. Determine how much will be in the account 10 years later if the account pays 8% simple interest. So how much will be in the account 10 years later if it pays 8% simple interest? So it's simple interest now, right? So we use the capital I And A is P naught plus I, that formula. Our R, as you can see, is 0.08. T is 10, 10 years. P sub 0, right? That's the initial amount, the $4,000, right? The 0.08, the R, that came from here, the 8%. Capital I here, right, is P naught times R times T, right? That was a formula we saw before. That's how much total interest we're going to will accumulate in the account. So that's 4,000 times 0.08 times T, which is 10. We get this. So then the amount, the balance, the available balance, will be this, P0 plus I, which is this amount. So we have $4,000 plus $3,200, and we get $7,200. So that's what we get. Now, again, I could go through the calculations for 10 years. I just did the first 5, so just to illustrate what's happening. But it's really just like the first example. We have a starting balance, which in this case is 4,000. We get the interest initially, and that interest amount doesn't change. We just keep adding it on each year, as you can see. So the ending balance, right, that becomes our new starting balance. We add on the interest, new ending balance. Becomes the new starting balance, add on the interest, and keep going. Okay? I mean, if you want to do this for 10 years, you would have to do, looks like 5 more rows. But we don't have to, with the formulas help us. Okay. But now, let's suppose instead we were compounding, and we're compounding annually. Well, based on the formulas alone, we can see how much will be in there. Our R is 0.08. Our N looks like 1. And our P sub 0 is 4,000. That's what's happening here. And so capital A then, right, the balance would be that formula. We just plug it in. N is 1, right? Because we're compounding annually once a year. We have R time, and we have N times T. And we end up with this amount. Good. But notice also, again, I'm just trying to illustrate what's happening. Initially we have $4,000. We calculate the interest. That's what the 8% is. And our ending balance, right? We just balance plus the interest. That becomes our new starting one. We recalculate the interest, which is 8% of this. That's what the 8% is. That's what the APR is. You use that to get the interest in a year. And we add that on, right? And so we're not adding on the same interest. We're recalculating it. And we make more money, actually, this way. That's our third example. Okay, now, before we get to this one, let me just do this. Again, I can't see your faces, so I really want to make sure everyone is learning this. I mean, I know I'm going kind of slow, but again, I don't know everyone's math background, so I have to be a little bit careful. That's just how I am. Oh. All right. Does anyone have any questions? Okay. Well, let's keep going then. I mean, all right, let's keep going then. Well, here's another example you guys are going to do. If I can get to it. Here we go. So this is another example. Here you're going to try some calculations on your own. Here, basically we're assuming the amount. We want to determine how much will be in an account 5 years later, assuming we deposit $10,000 and our APR is 5%. And then you're going to see, okay, what if it's compounded annually, quarterly, monthly, and daily? Annually, remember, that's when it's compounded once a year. Quarterly, that's 4 times a year. Monthly, I think I said already, is 12. And for daily, there's 365 days a year. So that would be 365. So I want everyone to try this out now for about like 4 or 5 minutes. Then we'll do it together.